That's all I'm looking at. I can't. I got 30 years. I come 30. That's on me. All right, just throw it on. See what happens next couple days.
All right, hello, testing, can you hear me? Everyone hear me? Okay. All right, so 6 o'clock has come and gone. This is the Carpinteria Groundwater Sustainability Agency's Groundwater Sustainability Plan Community Meeting number 5. And I think, what did I do with that? Yeah, so some of you have been here before, some of you I think maybe are first timers. There's some information on the table about the GSA and Sigma and the Carpinteria Groundwater Basin. We've been doing these community meetings for, I guess, 5 months. Time really flies. And we've been slowly crawling through the sections of the Groundwater Sustainability Plan as the technical team, which is working on the plan itself, grapples with these issues. And if you were here last month, you know we talked about the sustainable management criteria generally. We talked specifically about seawater intrusion, kind of went into that. And we're going to talk a little bit more about that. It's important that we make sure everybody understands what these decisions are and what the sort of bookends for those decisions are. This meeting is also being recorded and streamed, so I'm also talking to those folks out in the internet watching. Our speaker tonight is Dave O'Rourke from GSI. He's a member of the technical team. We also have Mike Burke from Pueblo Water Resources. He's here as a technical supporting panel member. I'll be sitting on the panel as well. And the way we've been conducting these meetings, and I think we'll continue to conduct it tonight, is we do a slide presentation, talk about the issues, and then if there are any questions, we try to hold them to the end. If you just can't wait, you can raise your hand. We'll entertain your question. But really, what we'd like to do is get through the presentation, and then we can take questions and answer them as a panel. So with that, I'm going to have Dave O'Rourke come up and walk you through the things that we're going to talk about tonight. Thank you.
Thanks, Bob. Okay, so I'm Dave O'Rourke. I'm a hydrogeologist with GSI. Going to briefly go over a few things tonight. I'm going to just do a quick review of GSP development and what the sustainability management criteria are. Then I'm going to go back over where we landed on the seawater intrusion discussion last month. I'm not going to revisit all the data that I presented last month, but just sort of cut straight to the where we landed. And then I'm going to spend most of the time talking about the SMCs for groundwater level decline and reduction of storage, which are one and the same for our purposes. So just in terms of the flags in my way. Huh? No, this is good. Just a slide on schedule, There we go. So, we spent a couple of months, basically educating, giving public education on groundwater conditions and hydrogeology and the status of the basin. We wrapped that up before Christmas. And then in January, we moved on to the sustainability criteria. January was just sort of sustainability criteria in general. Last month was more focused on the seawater intrusion, and today's going to be focused on the water level and reduction and storage, as I mentioned. Hopefully, the April one will wrap up the sustainability management criteria discussion, and we'll move into implementation and the projects and management actions as they pertain to the basin. And then come fall, we'll be assembling the document and getting ready to submit it for public review and ultimately to DWR in January. It's a little closer on the schedule. So yeah, today we're going to talk primarily about water level declines. In April, hopefully we'll wrap up the SMC discussion. We'll be wrapping up the water level discussion, and then the other three criteria, I'll remind you what they are. They are of lesser significance in this basin. And then in May and July, we'll be talking about projects, management actions, and getting to the finish line. So a quick review of SIGMA and the criteria. So these are the 6 sustainability indicators. These are the things that every groundwater sustainability plan needs to address. As I've mentioned more than once in the past, we think seawater intrusion is the driver in this basin, so we started with that one last month. This month we're doing lowered groundwater levels, reduction of storage, and then these last 3 I'll touch on at the end of today's presentation, but for various reasons that I'll briefly discuss, they're not as significant in this basin as they might be in some other basins. Just a reminder of some of the most significant definitions and acronyms, because there's a lot of acronyms. The RMS is representative monitoring sites, so like I'll be talking about RMS wells. Those are the ones that we're picking to measure the criteria. And the important sustainability management criteria are MTs. That's where if you exceed it or go below it, that it triggers some sort of action. So I'm going to be constantly using the acronym MTs tonight. And then MOs are objectives that are goals. They're like, with respect to water levels, they're higher levels. They're kind of aspirational. They're where you would like your water levels to be for operations. But in terms of, what you get dinged for, you don't get dinged if you set a measurable objective of 100 and you only get to 98. That's not a problem. The MOs are just goals. The MTs, however, those do trigger an action if you don't meet the MTs. If your MT is 100 and you show up at 95, and that happens, repeatedly, then that will trigger some sort of action. That's the regulatory criteria. And this is just a simple little graphic to kind of wrap up all of the acronyms I'm talking about. So the sustainable management criteria are collectively the MTs and MOs. So that's what those are. And you measure their effect at the RMS wells that you select. Now those RMS wells are a subset of the entire monitoring level network. I believe the district currently monitors 40 some odd wells for water levels and or water quality. We're only talking about, 10, 12, 15 RMS wells. And you should pick them carefully, because that's where you're going to be measuring your success or your failure. So, it's good to, set yourself up for success and pick things that, don't be too aggressive in your goals, and pick wells that have a good period of record or what have you. And then when we get to projects and management actions, those will also be, their effects will be measured at the RMS wells. So everything, it's very RMS-centric in Sigma land. Okay, so now I'm going to double back again to some discussion of seawater intrusion. Again, I'm not going to represent the 20 or 25 slides that I presented last time, but I am going to hit the high points of it just to remind you where we are on that. The undesirable results, obviously, that you want to avoid. These aren't technical descriptions. They're just, you want to avoid saline water reaching wells inland as a result of migration of seawater. You recall I showed a couple of cross sections last month that showed how seawater can, get into the sort of northern part of the basin. So we selected some RMS wells for the purposes of keeping an eye on seawater intrusion, and it's basically any well that was close to the coast. Without explaining why, there's some faulting here, the Rincon Creek fault and the Carpinteria fault. For technical reasons that you can go back and review that cross-section to confirm, there's really no danger of seawater intrusion, in this part of the basin because they're sort of protected by the faults. But north of Rincon Creek Fault, we basically selected every well that the district is currently monitoring, that's along the coast. So that's the big green dots, this, and this. Now these small green dots they're not all going to be implemented, but in general, those are some proposed locations for future monitoring wells to monitor seawater intrusion. I'm sure that's a lot more dots than will actually be, wells installed, but I believe there's already some grant funding applied for to assist with this monitoring network. They put some dots on a map, but they're not, it's not set in stone that those have to be where the wells are. There's going to be some siting studies. This analysis hadn't been done yet at that point. So my point is that there will be future, monitoring wells along the coast to complement, the ones that are currently selected as along the coast. So to remind you, the regulation in Sigma says that you determine the minimum threshold in terms of an isocontour line. So that's a line that is of equal concentration of chloride, which is, in salt, that you want to make sure everything on one side of that line is above that threshold and everything on the other side of the line is below it. It is not mandated that you have to have the data to actually define where that line actually is right now. But if we draw a line on the map, as we did, and I'll show you, it does kind of commit you to improving your monitoring along that line. And that's pretty much where we are. So I threw a lot of different data onto this figure, one of which is, the maximum historical chloride concentration in wells that are currently monitored in the basin. You can see most of these, or maybe you can't see, but most of these chloride concentrations are below 100. So just for your reference, the secondary maximum contaminant level for chloride is 250 milligrams per liter. It's a secondary MCL because there's not a human health impact. Primary MCLs are for things like arsenic and nitrate that do have a demonstrated human health effect. Secondary MCLs are taste and odor issues. So after some discussion with the technical group and with Bob, we settled on this plan. We all agreed that it's really not feasible to actually, install monitoring wells right on the coast. It's public lands. I'm sure the Coastal Commission would have a few things to say about that. And that would be really aggressive anyway, to try and stop everything right at the coast. So the general philosophy we wound up with is we'll put a measurable objective line. So this is sort of, again, aspirational goal of 100, which right now, most of the wells are near that. And we'd site that halfway between the coast and a line that connects the current active wells in the basin. And then our secondary, our MT line, minimum threshold, would be 250. That's the secondary MCL. And we'll define that line by drawing a line through the active wells that we're aware of. So we, reviewed the district's data set. Like all data, it's incomplete, but we've got a fair handle on the wells that are currently being used, and they largely are connected by this 250 milligram per liter line. So that's the minimum threshold, and the minimum objective line is here. So the MT line is more rigorously defined because it actually connects some wells. The measurable objective line is less rigorously defined because right now we just said, all right, we'll put it halfway between the coast and receptor wells with the idea that, that'll give us a front line of defense and we can see what's going on at that line. If we see consistent changes in water quality at that line, then probably some action would need to be taken. It's worth mentioning that you can see there's a couple of wells here that have very high chlorides historically. That's near Arroyo Paredon. The water coming out of that creek is of pretty poor quality. It would take a little more robust study, but there's probably some geothermal spring or something that discharges to that creek. In any event, the surface water has been sampled in that creek, and it is of poor quality. And these wells here have got chlorides that are already above that secondary MCL. So anything we define, we're specifically excluding that area from consideration because it's not up to us, it's not up to Sigma to improve water quality to some, criteria that it doesn't even meet historically. So that's our approach. We're going to propose to GWR a measurable objective line of 100, on the coast side of currently active wells, and an MT of 250 along the line of the active wells, and it will exclude anything around Arroyo Paredon. So, we've talked about it. I've talked about it with Bob. We're all on board with this. So if, when I'm done, if you have any questions or comments or think this is irrational or think it's a good idea, happy to listen to your input. Okay. All right. Now I'm going to get into some specifics about these criteria, sustainability indicators, the lowering of groundwater levels and the reduction of storage. These two are very highly correlated because obviously if your water levels decline, then there's less groundwater in storage. There are alternative ways of evaluating storage, but Sigma does allow you to use water levels as a proxy for this, sustainability indicator, and every basin I've been involved in, that's what they do, and it seems like a perfectly reasonable approach to us, and that's what we will do. So the MTs that we come up with at the RMS wells that we select, they'll be the same MTs for both. So the things, the undesirable results that you want to avoid, undesirable results need to be significant and unreasonable. Those words are in, the law, so they carry some import. But one that's a big issue in other basins I've worked in is private domestic supply wells. Those people need to be protected. from declining water levels where they can't even supply water to their own homes. Well, that's not much of an issue in this basin. There are, there might be one. I mean, the district basically serves all of the area. There's a couple of private wells that people might use for lawn watering. You know, you're not protected for your lawn watering. Yeah?
We are talking about domestic wells.
Yes,
Of course,
domestic wells.
Many private wells used for agriculture.
Yeah, not ag wells, domestic supply wells. Thank you. You know, for production wells, for municipal production wells, you don't want water levels falling below the top of the screen. That's just an operational, you know, condition that is ill-advised because, you know, it tends to oxygenate the water that comes in, so you just avoid that. Or decline in yields of agricultural wells. You know, the Groundwater Sustainability Public Advisory Committee is now a functioning body, and, you know, we'll be talking to, you know, the agricultural, well, the farmers in that group to find out what they experienced, you know, during the recent drought. You know, were there really any, you know, losses in yield or what have you. So you have to demonstrate to DWR that you at least analyzed some data. You know, one of the basins up north initially got rejected because they just said, we'll just take 30 feet lower than current levels. And they said, no, we need a little more than that. So the things that you would analyze are, you know, well location, depth, screened interval, pumping patterns, and, you know, and public outreach to see if there were any undesirable effects, you know, observed over recent conditions. This last thing here is just what I mentioned, that the reduction in storage criteria can be and commonly are defined with the same water levels as water level SMCs. Okay, this is a draft of proposed wells that we're considering for RMS wells. This is not a final map. The final map will be coming along, but, you know, we essentially started with all the wells that the district currently monitors. We didn't go looking for other private wells that we might be able to access. You know, we figured 40 is a good number to start from. Let's look at what we have with these 40 and, you know, winnow them down from there. The things that we look for when we're selecting RMS wells is, you know, a long period of record, and a lot of these wells have water levels going back to the 40s, which is just marvelous, I gotta say. It's good to know the construction details, like the top of the screen. That's not always known with these wells, but in the future we might have to, you know, look into getting that data over the course of the implementation plan. It's preferred if it's a dedicated monitoring well. That's, you know, DWR realizes that this isn't a perfect world and you're likely to have to use either production wells or ag wells or private wells initially, you know, and then hopefully we'll be installing dedicated monitoring wells as the implementation period progresses. You know, spatial distribution of wells and data gaps, you know, accessibility for accessing for monitoring, and then, you know, are they representative? So I'm going to go through a series of about a dozen hydrographs for wells, you know, for the wells that are, you know, the big blue dots on this figure. The yellow dots are wells that are currently monitored by the district, so you can see the blue ones are a subset of those. So we'll be thinking about these things, you know, I mean, we thought about these things when we, you know, basically, you know, we said, all right, we want good spatial distribution. Let's just pick, for starters, let's pick one for, you know, per each section within the basin. So that's where we went for. This is, I don't expect you to read this, but you can check it, you know, when this presentation gets posted. These are, you know, the data that we have on those proposed potential RMS wells. So okay, where do we start? Where do we start the conversation for minimum thresholds on these RMS wells? Well, for starters, we want to look at the period of record of that well and compare it to the water level record in the wells around it, and convince ourselves that this is in fact representative of the wells in that area. And in this, like I said, in this instance, we're just having one per section. And that's, as straight ahead as just plotting all the hydrographs on one graph and seeing if there's anything unusual about the one you've selected. And then, again, where do we start? Well, just as a start of the conversation, I proposed, let's just look at the recent low water levels, right? In the drought 2016, 2018. Let's look at those water levels and start with there. Are those, is it crazy to consider those as an MT? Well, I don't know. Let's think about a couple of things. Were there undesirable effects observed anywhere around there? Were the water levels brought down into the well screens in the district wells? Did the farmers in that area, did they have to turn off their pumps every couple of days because they were lowered in water levels so much? If not, I would propose, for the sake of conversation, that it's reasonable to set the MTs a little lower, than the recently observed water levels. Why do that? Well, if undesirable effects weren't observed, then I'd say it's reasonable to propose that. And, you want to set yourself up for success. There's no upside to proposing MTs that are too restrictive. So I would say if there's no undesirable effects observed or reported, if we're well above the top of the well screen, then, I'd say it's okay to propose an MT that's lower than the recent low. Not 100 feet lower maybe, but 10, 15, 20 feet lower. That way, we're not going to, if we go back into drought next year, we're not going to automatically, be worrying about, oh my gosh, are we going to be in exceedance right away the first year? So it's just a matter of, not being too aggressive, being a little conservative, and like I said, setting yourself up for success. Now, I'd say along the coast, that's probably not a good, tack to take. If seawater intrusion is a potential, effect, then you probably don't want to propose water levels that are lower than the recent lows. So we're going to have some significant conversation about a couple of those wells as I run through these hydrographs. So inland, I think, it's not unreasonable to propose. Along the coast, probably not reasonable to propose. Another thing to keep in mind, and we're not really going to address this today, is, how do you evaluate these MTs? Is it like, well, I won't ask the question, I'll tell you, it's specifically we're not going to define it as, okay, one well got exceeded, boom, that's an undesirable result. We need to immediately go into management actions or do a study. Groundwater moves slow, right? So other basins that I've worked in, it's at a minimum, they do like 2 years successively of water levels that are below the minimum threshold, or 2 years where you take the average of the spring and the fall. But in any event, I would never propose that if one well exceeds 1 MT one time, you spring into action. You wait and you evaluate. And if it's, persistent over a couple of years and a couple of different wells, well, then it's valid to, think about taking some action. And usually the first action is a study. You don't immediately run to, oh, we need to start injecting water here, or we need to, limit pumping. The first thing you do is take a closer look at what you're dealing with. Additionally, depending on the area, you can write your interpretation of the MTs as being representative of normal conditions, I mean, we just went through what could be called a 7-year drought, and that's not really normal. Might become more normal, right? But you can write it as, representative of non-drought conditions. So if you're in a really significant drought, you can try and write yourself out of immediately having to comply with the MTs. Now, that's been proposed in other areas. I don't know, we'll see what DWR has to say about that. But it's not unreasonable to propose, hey man, if we're in a 7-year drought, that's not normal. So, we're going to think about all these things. Now okay, so that's for the MTs, which, like I said, those are the regulatory limits, right? Those are the ones that are going to trigger some action if you don't meet them. The measurable objectives, which, like I said, they're just sort of your goals, your aspirational levels, you can take a sort of a broader view of those. You do have to define an elevation or a level. But you can just look at the hydrograph, as I'll show you 10 or 12 of these things, and just say, this is where it was before the drought. RMO, we'll just pick that average level. Or in a condition where which is not the case in this basin, where water levels have just declined for 30 years, the sigma baseline is to bring it back to 2015 water levels. So, again, that's not really the case in this basin, but you can look at it and say, well, okay, here's where it was in 2015. Here's where it was, before the drought, before 2013. Let's pick one of those levels. Okay, moving into the hydrographs. So all of these hydrographs are for the various wells that are in this section, right? So we're up here in the northwest part of the section, not buttressed up against Montecito, but up there. The heavy blue line, that's the one that we're proposing as the RMS well, and all of the other thinner lines are just the other wells that are in that section. So, I would argue with you that based on those hydrographs, this well is perfectly representative for that area. It's got a great period of record, goes back to like 41 or 42. All of the declines, all of the droughts that are obvious in the RMS hydrograph can be seen in the other hydrographs. So so question one, is this representative? Yes, I'd say it's representative. Were there undesirable effects reported up here? Not to my knowledge, but now that the GSPAC is a functioning entity, we're gonna be talking to the farmers on that committee and find out what they've experienced in the last 7 years. So again, as I mentioned earlier, water levels, could go lower than the recent lows as long as they stay above screen. Now, in this particular example, unfortunately, we don't know the top of screen. Do we know the TD of this one? Anyway, I should also preface this conversation saying these aren't final, all right? I'm presenting, the status of the conversations among the technical group. So if I don't know the total depth right now, you can rest assured, it's going to be taken into consideration. But, so based on the conversation I just had with y'all, okay, here's our recent low. It doesn't seem unreasonable to think that we might be able to define the minimum threshold about 15 or 20 feet lower than that. And the measurable objective is, we just put it up here. That's sort of like in, the average water level prior to the drought, And again, if in 20 years from now, your water level's not at the MO, it doesn't matter. The only thing that matters is if you're consistently lower than the MT. So just like we don't want to define our MT, too aggressively, we wouldn't want to define the MO higher than, any historically observed data. That would not be setting yourself up for success. So this is the kind of thing I'm going to run through for several more of these. And again, these aren't final. We're not even 100% sure that each one of these hydrographs that I'm presenting will actually end up being an RMS well. And we might kick a few off the list based on sort of the things we're seeing or data or lack of data. But these are the discussions we're going to have for the next 8 or 10 slides. Okay, so in general, we're going to move sort of this way through the basin, starting up here, going down along the northern side, then doubling back and coming up, you know, the coast side. So this is this general area. Again, the dark line is our proposed RMS well hydrograph. The other hydrographs are other wells that are monitored. So you can the 80s and 90s drought. These other wells don't come to the recent period of record that this one does, but you know, based on what we see on this one and the RMS well, I'd say yes, it's representative. It's reasonable to use this one. Now in this case, we do have the top of screen, and it is 230 feet lower than the lowest recent water level. That's a pretty good buffer in my book. So I would say in this one, it's not crazy talk to suggest 15 or 20 feet lower than the recent low water level. Again, if we stay in drought for another couple of years, that we've got a little more buffer. If there were no undesirable effects reported, then it's defensible. So that's where we landed on this one. Okay, now we're over here, moving to the east and southeast. Again, the dark blue line is the one we're suggesting. The other ones are just other wells in this section. This one has got a great period of record, but I believe it's no longer being monitored, or it was destroyed, so that one is no good. These other ones, the red and the orange trace, they're really shallow. So, that presents its own set of potential problems. So in this case, the top of screen is 365. The top of screen is 235 feet below the recent low water level. Again, that's plenty of buffer. And, I would, again, argue that putting a little bit below the recent low is not an unreasonable proposal. And I've said it once, I'll say it again, on these not reported undesirable effects, we really need to formally poll the GSPAC and other members of the ag community, in the basin to confirm that, instead of just kind of going, oh yeah, nothing happened. We'll document it and make it part of the argument. Okay, now we're over here. This one's pretty far up, sort of uphill in the basin. It's got a really good period of record going back to the 40s. You can see the drought of the 50s in it. The drought of the 80s and 90s is almost just a blip, but the recent drought certainly shows up. Another thing I'll mention about these hydrographs is most of them stop in 2021, and we'll need to update them with last year's data, before we complete this analysis. But they were generated for the Chapter 3 of the GSP, and it was still 2022 then, so we didn't have the calendar year data at that point. Okay, and so this one, it's not as straightforward, okay? First of all, we've got really old water level data that shows a much lower water level than the current recent lows. However, things were a lot different in the 50s. There was no state water. There was probably a lot more agricultural use. So to propose, that level is probably not going to fly. It would be a tough sell to DWR and probably other stakeholders. And another thing that makes it slightly problematic is that, you know, the top of the screen is, I mean, during the recent drought, you know, they were below the top of the screen. So our ideal consideration that our MT would stay above the top of the screen, we don't quite meet that criteria in this one. However, presumably it's an agricultural well, and it's 480 feet deep. So, you know, they still had a couple hundred feet of saturated thickness. So I'm assuming they were probably still using it. But because of those, you know, potentially complicating factors, you know, if we're looking for wells that I'm talking about tonight, if we're looking for wells to cull from the RMS network, you know, we might think about this one. It's also way up, you know, in the basin. So, so I don't know. Like I said, you know, we're not at a final resting place on many of these, and this is one that has got some issues that, you know, need to be sorted out. All right, let's carry on. All right, and now we're down here. Now this well, it's right as Rincon Creek comes into the basin. There's not a whole lot of other wells in that section. We only had hydrographs for 2. So the dark blue one is the one that we're talking about. So I look at this hydrograph, the dark blue one, and see just how steady that water level is, you know, for 20 years. And that thing screams to me that it was likely a spring-fed flow in the creek during that wet period, and the well is probably screened shallow enough that it's, you know, very closely impacted by the water level in the stream. So, can you manage spring flow up in the mountains? I'd say no, you cannot. So maybe this isn't a good one, but on the other hand, you know, during the drought, okay, so when, you know, possibly that spring dried up due to the drought or whatever else was going on up there, you know, then you can see water levels dropped. However, you don't want to set an MT based on these low water levels because you got no control over that, right? So it was suggested by one of the technical group members. They said, well, you know, you could keep it. You could set the MT at this level, but just write it such that it only applies during wet periods, right? So if you're cruising along here in the 90s and you hit 2000 and it's still wet, and all of a sudden you start seeing fluctuations like this when it's raining, well, that's probably due to pumping. And so maybe you could write it that way. Again, we're not at a final decision on any of these. That seems overly complicated, but it's something to be discussed. But I you know, mainly just sort of wanted to show the hydrographs so you could see. I mean, that steady water level over all that time, you know, that seems to me like it's, you know, impacted by a very steady stream flow, which is probably due to uphill spring flow of some sort. Okay, now we're starting to double back to the west. So we're in this area here. The dark blue is the one we're proposing. You can see it's very similar to the other one that's got the longer period of record. I can't remember why we chose this one over the other one. Well, it's a district well, right? Smiley. That's a good reason. So you have access to it and control. But in any event, you know, those two hydrographs are very similar. So I would say yes, this is certainly representative over the past, you know, 40 plus years. Again, no undesirable effects reported. We'll check with the ag representatives in the area. The screen interval is, you know, almost 250 feet lower than the recent low water level. So it seems like we might be able to, with the straight face, propose 15 or 20 feet lower than that recent low. You've heard me repeat the same arguments a couple times now, and it's a repetition of a theme. It's not the last time you'll hear it. But so again, those are the two things. Is it representative? Do we know the screen interval? Are we staying well above it? And were any undesirable effects reported? For each one of these RMS wells, we'll have to individually address those questions. All right, now we are here in this section. Again, just quite quickly, yes, the heavy blue line is representative. Now this is let's see, this is the Lions well. Okay, anyway, looks like there's some pumping effects in this hydrograph that we need to have a little closer look at. You don't want your MT set if every time your neighbor flips on his well, your water level drops 50 feet. That's not what Sigma is supposed to be about. So, but even with that being said, it's certainly representative since, since the 80s. Starts in, you can see the 80s drought, you can see the recent drought, just like the other ones, so it is representative. We don't know the screen depth on this one. We'll double check on the total depth for the final analysis. But again, I would say we could go a little lower than the recent low and, get by with it. Okay, now this is the one where we've got the headquarters well and the Santa Ynez well. Santa Ynez well, right, is the old production well, and the headquarters well is currently in production. So these are controlled by the district. That's a big plus. Some of the other wells in the section are also shown here, and you can see the 80s drought and the recent drought are shown. This one is even more susceptible to pumping interference effects from a nearby well because they're in the same yard. So we did try to screen those out. I'd say we need to try a little harder. Some of these 50-foot drops are likely, taken when the headquarters well was pumping, and we don't want to base anything on that. The top of screen is about 150 feet below the recent lows. Again, this will be, the final decision will be with Bob and the technical group, but I'd say it's okay to at least consider, a little lower than the recent low. All right. Now here's one where we really are still scratching our heads. So this section. This is where the district's sentinel wells are, right? So we talked about those last week, and I'll be reviewing some of that data here in a minute. They have 3 discrete wells, A zone, B zone, C zone, with increasing depth, and we're definitely using them for seawater intrusion RMS wells. So this red line is another well. There's an old ag well that's just on the other side of 101, I think. But I wanted to throw it in just to show you that, this is, the y-axis is depth to water. So if your depth to water is 0, that's an artesian well. This is what a hydrograph for an artesian well looks like. At that point, the water's flowing out the top of the well if you don't have a pressure rated cap on it. Now, that's not a normal condition. If Bob pointed out these time periods where this is happening, if you overlay those with the cumulative departure curve for precipitation, those are wet periods. So, we wouldn't be wanting to set an MT there, but I just thought it was interesting to show you. This is what an artesian well hydrograph looks like. So, toward the end of this lengthy period of record for D1, we have another one, D2, and then at the very end of that period of record, we've got the Sentinel wells. Those were just installed in 2019. So I'm going to focus in, on the x-axis a little closer on those and talk about the issues and the potential complications of using them. And again, we're still talking about this one especially. Where are you? Okay. So the heavy lines on the right that start at the end of 2019, those are Sentinel well water levels for the A zone, B zone, and C zone. These other ones are, the red one is the long period of record that I just showed you for D1. And this one, there's just a few years, like 5 or 6 years period of record. I'm not sure what happened, but we don't have the water levels anymore. But it just goes, my point here is that the Sentinel wells, they didn't capture the recent lows during the drought. They didn't pick up until 2019. So trying to set a water level MT, based on a 2 or 3 year period of record is a little dicey. If we took our criteria that we were talking about earlier and said, oh, we'll just set it at the recent low. Well, that recent low is, in all likelihood, it was a lot lower 5 years ago. So you got that problem. And then we said, well, okay, we could just set it based on what this one shows because it looks like it's about the same. Well, maybe, but maybe not, So trying to set an MT based on data from another well has got its own set of complications and probably not advisable. So, I just show it to you to, make the point that the period of record for the Sentinel wells is really not long enough yet to pick an MT based on that water level data. And that's not even getting into the fact, do we even want water level MT? Do we even want to use those when we're already using it for the seawater intrusion criteria? Because that criteria is based on chemical data and, we're already using it. And, there's the potential that if we were to set, okay, let's just say for the sake of argument, you said, all right, let's just set it at the recent low here, and we go back into drought next year, we could immediately be in exceedance. I'm not saying that should never be considered, and I'm not even saying it shouldn't be considered now, but it'd probably make a lot more sense to think about it 5 years from now when we, do the revision of the GSP and we got more than 2 years of data. And then, this is just a reminder of the water level and the chloride issues at the Sentinel wells, right? So we're here at the Sentinel wells. This shows the screened interval for the 3 different wells. The A zone, came down in 2016, bumped up in 2017, down, so it's got the recent drought signature, pretty representatively year by year. And chlorides there are low. They've not moved, they're very steady. The B zone well, we don't have the deep data. The transducers were set a little shallow, so, be problematic picking an MT based on that data. And additionally, even though water levels were low, the chlorides declined, so what's up with that, I ask you? And then the C zone, water levels have declined and chlorides have increased. I just present all this data, like I said, to tell you that we're still scratching our heads, especially about this, There's some valid reasons not to include it. It's already being used for seawater intrusion. It could, basing it on water levels from other nearby wells is problematic. Basing it on water levels that you see based on such a short period of record is problematic. So, we're going to keep talking about it, and presumably when we come back next month, we'll tell you what our recommendation is. Okay, now this is sort of a combined couple of sections. There's a couple of wells that were, historically monitored here. Now this is in the area between these 2 faults, so it's It's really not representative of the larger part of the basin because it's, you know, it's hydrologically distinct, hydrogeologically distinct. And there's not a whole lot of groundwater use in that area, but we took a look at what we do have. You know, is it representative? It's hard to tell because there's so little other data to compare it to, but you know, under these, it does show some declines during the recent drought. You know, the 80s and 90s, there are some declines in, you know, 80s and 90s, but, you know, in this one, we don't know the top of screen. But, you know, just for the sake of conversation, we're sticking with our, you know, original proposal that a little bit lower than the recent low should be okay. Measurable objective would be where it was before the recent drought. You know, I know there was some discussion about maybe considering this a separate management area. I'm not sure if that will happen. You know, you can base MTs on different wells based on different criteria. There's no law that says you have to use the exact same set of criteria for every well. So we'll see, you know. To be continued. But so everything I presented, you know, in the last 10 or 12 slides is just the discussions that we're having. Some of them seem pretty straightforward. We're 250 feet above the screen. It's totally representative. We can live with it a little lower. We're far inland. Some of them have some other complications. You know, we were below the screen in that one ag well lately, or the one that's right on the creek that seems to really mimic flow, you know, stream flow conditions. But in the final analysis, the final document, each well that we select for an RMS well will have its own discussion on all of these factors. And it'll be laid out plain as day for DWR, you know, to read and consider. So that's, you know, that's where I'm leaving it right now for the water level and the reduction in storage sustainability indicators. Now I'm just going to kind of quickly give you a little prep on these final three. You know, I'm not really addressing them right now, but, you know, I'll give you a preview. The first one's water quality degradation. I just want to start off by saying SGMA is not really designed or intended to manage water quality on a gross basis. The idea is it is set up to avoid degradation of groundwater quality due to groundwater use. So, you know, a classic example is seawater intrusion. If you pump the water levels down 200 feet right by the coast, you know, water quality is going to decline. That's, you know, that's an obvious one, and it's so obvious it's got its own indicator. Another, you know, stupidly obvious one would be if you've got a big, you know, plume of contaminants, then you don't want to go in and put a bunch of production wells right down gradient of that and, you know, pull the contaminants into your wells. Again, these are sort of painful restatements of the obvious, but that's the sort of thing, you know, that you want to avoid. In some cases, if you know, the more you pump water down, I don't believe it's the case here, but lots of places in the Central Valley, the deeper you go, you know, the worse the water quality gets because the water's older, right? And so it's had time to dissolve the minerals in the sand. So that would be an example of water quality degradation due to groundwater pumping. But in our case, you know, we haven't identified any instances of anything like that. But we will have to select, you know, some RMS wells as a monitoring network. These are the wells that are currently monitored by the district. There's about 30 of them, I believe, where they collect water quality samples and send them to the lab and get them analyzed. So any RMS wells for water quality are going to be a subset of this. And then, let's see what I got next. So, you know, this is the existing monitoring program that the district engages in. They've twice a year data collection since 2000. They do general minerals, cations, anions, TDS, things like that, nitrates. They do currently collect surface water samples at 4 or 5 creeks in the basin, and they're proposing to continue that, even though it's not really required by SGMA. There are areas, like I mentioned, Arroyo Paradon, where the surface water and the groundwater quality are clearly interrelated. So, currently the district isn't proposing to discontinue their surface water sampling. Again, this is what I started with. SGMA is not really intended to manage water quality, and specifically not to improve water quality. So we would need to select, like, let's just use total dissolved solids as a criteria, right? The higher TDS is, that's sort of saltier water. We would need to pick, a TDS concentration where we said, you get above this and you've exceeded your MT. But it does not, I would say, we would base that on historically observed data and not through, like I think the primary or secondary MCL for TDS for drinking water is like 500 milligrams per liter or parts per million. We wouldn't do that if the water quality in that area has historically been 600 or 700, which is definitely not uncommon. We also would specifically not use what has been published in the Regional Water Quality Control Board's Basin Objectives Plan because, as Robert Marks said, he goes, they don't even know how they did that, and lots of them are defined, at levels that are clearly lower than what's coming out of the ground right now. So we would not do that. What we would do is probably go, for 6 or 8 or 10 of those 30 wells. I mean, my initial thought was like, pick the maximum, that's been historically observed and set it there, or something like that. You definitely don't want to set it lower than has been historically observed. I guess that's my primary message here, because, it's just, you'd be setting yourself up for failure. So that's what I'm saying here. We would say the criteria would be based on historical water quality data, not some external criteria that might be published somewhere. And again, we can always look back to, well, what was it in 2015? Because that's the baseline date for the start of SGMA. So again, I said I wasn't getting into it, and here I got into it. But probably next month we'll come with some proposed RMS wells and some proposed, MT criteria for at least the most common, constituents that are currently monitored for by the district. All right, the next one is interconnected surface and groundwater, surface water and groundwater. I certainly don't mean to minimize this. It will have to be addressed, but the creeks in this basin are, losing creeks, probably more like C. When they're flowing, they percolate water into the aquifer. Maybe right at the edge of the basin, the water level might be right up there, but in general, it's this. Now, we can't just wave it off because there are a couple of groundwater-dependent ecosystem areas that we weren't able to screen out in Chapter 3. But in general, the creeks in this basin are this. So there's really not, any sort of long-term interdependence between the creek flow and the stream flow. And then a couple of things. These are both based on some, personal communication that I heard or had with DWR. You guys might have heard last month there was I think there were 6 basins in the San Joaquin Valley that they got their plans denied. During the public meeting or presentation on that, I forget the guy's name, the head of DWR, he said, that when it comes to this sustainability indicator, he said he admitted that, the DWR guidance was vague, and there will be additional guidance coming, and that, for that reason, they're not rejecting plans based on this indicator at this point. And then I had a conversation with Dane in the Fresno office about a year ago, and he said it's likely to be a model-based analysis in the future. You'd have your groundwater model, your basin. You have a project you want to evaluate. You run the model without the project, and then you run it with the project, and you compare the modeled flux between the stream and the aquifer, based on the model runs, because it's just flat out impossible to really calculate the flux between a stream and an aquifer. You can make a guess if you've got a high density of, piezometers and monitoring wells. So you got good control on the elevation of the stream versus the aquifer, but really you can't measure it. So in the future, like I said, it's probably going to be a model-based analysis to do this. Having said that, the model that the district has right now cannot do this because they specifically prescribe their assumed percolation from the streams into the aquifer. There is a mod flow package now, the stream flow routing package, where it does get calculated, but that's not in the district's model right now. 5 years from now, I'd say that'd be high on the list on things that you'd need to do to improve the model. But in any event, it's not a big deal in this basin because most of the creeks are in this situation where there's, even if you did depress the water table, you're not going to induce any additional percolation from the creek. So that's surface water, groundwater. And then the last one is subsidence. There will not be any RMS wells identified for subsidence. DWR has taken upon itself to institute a satellite-based data collection system for subsidence. It's called INSAR data. They can measure subsidence within plus or minus 0.1 foot in any given year. Subsidence has not traditionally been an issue in this basin. And so we won't be monitoring it with wells. We'll just be logging on to DWR's well site every year, downloading the most recent data and saying, yep, another year where there was no measurement greater than the error bar. So we're not waving it away. We'll follow the letter of the law. We'll use the INSAR data, but it doesn't appear to be an issue here. So what's next, just in terms of the next couple of meetings? So again, like I said, the plan is for the April public workshop, we'll come back with a final recommendation on these water level criteria, and we will run through the water quality and the discussion on the interdependent groundwater surface water interaction. And hopefully at the end of that meeting on April 19th, we'll be done with the sustainable management criteria discussion, and we'll be ready to move into projects and management actions, implementation, and really get to the meat of the matter. I just put this up there because, as I mentioned, the GSPAC is now a functioning entity. We had our first meeting a couple weeks ago. They are scheduled to follow this meeting by a couple of weeks, so we can present this here. The committee members can attend here or get the data, get the information at their leisure, and we can, go over it again with them at the PAC meeting. So the March 28th meeting, we'll be discussing what was presented here, April 25th meeting, we'll be wrapping up the SMCs and then the smaller criteria that I just went through. And in May, we'll be getting into projects and management actions discussion. So, questions?
I have a microphone if you have a question, and I'll bring it over to you.
Got a bunch of them, but I'll ask this one first.
When you're talking about water level in the wells, are you talking about static level? Because the more you talk about it, even if you have two wells within a certain proximity, and based on how old they are, who put it in, the quality of the construction, you know, one's doing 100 gallons a minute, the other one's doing 200 gallons a minute. They might affect each other, they might not, all of those things. So as far as getting something that really is meaningful for level in the well, how do you deal with that?
It is static level we're talking about. So if we want to, you know, well, plenty of the wells in the district's network now are ag wells, and if they go by to measure the water levels, they try to arrange for them to turn them off at least the day before, if not sooner. And if it's pumping when they get there, you either note it and take it anyway, or you just say, we're not taking that, it was pumping. But the short answer is yes, it's static water levels that I'm talking about. That's why some of those hydrographs, I said, yeah, you can see this thing, it's dropping down 50, 100 feet with some degree of regularity. That's pretty clearly probably due to pumping nearby. And so we really don't want to base anything on that either.
Yeah, and might I add a little bit to that. This is a topic that the district has struggled with for many years, trying to get the static level in a given well. And it comes with the territory when you're using private wells where, you know, their objective is to be pumping groundwater for irrigation purposes. And so we have to figure out, okay, when can you shut it down? You know, and there's cycles that don't necessarily match with our monitoring schedule. And so one of the benefits of having dedicated monitoring wells is we can actually put a transducer down there and it's continuously measuring. And so we see when the wells come on, when they go off. We can see kind of, you know, if there's a trend going up or down. And we've talked about maybe utilizing software to cull out all of those pumping rates and then actually come up with a smoother curve so we can see actually what the static level is.
Yeah, and you could do that. I mean, there's no reason, you know, if you've got an agreeable well owner, you could do that in an ag well. If they're letting you come by and tag their well twice a year, they may not be opposed to just putting the transducer in and making it easier on everybody. And then it's really, really easy to see what the pumping level is. And so.
And with the transducers, you can also kind of filter out neighboring wells, so you can see the influence of those in the continuous data, which is another challenge that you mentioned.
Another related question is, now, we have two wells that are monitored by the water district, and as far as I know, it's only a water sample that is taken. There isn't information about the level of the water and the change in the level of the water. Is that right, Bob? And if so, how many of the wells of those 40 wells are in that same situation?
We have several that are used for both water quality, well, handful used for both water quality and level, but in general, they're distinct. There's 30 water level measurements, and then there's, I don't know how many water quality we have.
About 30.
About 30,
and
yeah.
Maybe less than half are both.
A couple of questions. One is, do you have a feel for what the horizontal influence zone is for a well? I'm sure it depends on the permeability of the sediments and the rate of pumping, et cetera, but you know, how far away do you have to be before you don't really see too much influence?
Bob, that's one, sounds like more one
Well,
for
so
you.
it just depends on the drawdown in the well, depends on the static level and then the drawdown on the well when you're pumping it. So if you draw it down 100 feet or 200 feet in the well, that's basically a cone that comes up and, it's proportional to the distance you get away from the well. And so it really depends on how much they're pumping and how much they're drawing the actual water level down. We see in the wells that we have transducers, we see other wells having an effect on those monitoring wells. So we can see the curve of wells going on and off.
That kind of feeds back into Scott's question, how do you monitor a particular well, particularly when you're looking in terms of tens of feet to hit your MT when you have pumping effects from nearby wells?
Yeah, we try to filter those out is the answer. And, one of the things that we know about most wells operated in the basin are they don't operate 24/7. They're usually tied to some sort of irrigation schedule or some production schedule. And so you'll see them in big effect. And right now is a great example. No one's using water. The water level came up pretty quickly in the basin, in the wells that we've been monitoring. And that's likely because everybody turned their wells off because they don't need to irrigate.
Yeah, right now would be a really good time to get true static water levels.
Yeah. And I'd say too, the way the industry's headed is toward continuous monitoring. It's going to take a while to outfit, every, RMS well or every monitored well. But if you had that in all 30 wells, that sort of question would be moot. It would all be pretty clear. Transducers have hit the point where they're reasonably cheap. You get one for $1,000 or less, and 10 years from now, probably most of the district wells will have them.
Well, all the district wells already have transducers.
Well, I mean the monitored wells, or they would try.
Oh, I see. Yeah.
Yeah. Anything that you're monitoring, because I've given a presentation looking at some data up in the Paso Basin where you can see, you take a week and then a day and then hour, and you can just see the difference. And okay, what if you happen to take your hand measurement here? What if you did it 2 days later? It'd be 15 feet different. What if this well over here was on and you didn't know it? It'd still be another 15 feet different. So it's really a good question. It's a totally valid concern, and the industry is headed toward continuous monitoring. I'll just say that. Might take a few years to get there, but that's where it's going.
Yeah, and as we define, the protocol for measuring, we're going to consider all those types of questions, whether we are actually getting a true representative measurement or we may be subject to nearby well interference.
I have one last question. Arroyo Paredon has poor water quality. What's kept that water from contaminating the larger basin over time?
Maybe the rate at which it percolates into the groundwater basin. I know that we've had some anecdotal information that wells have been drilled along that corridor and that they're typically not very good in terms of water quality. And so I think there's a localized effect, but it hasn't really moved into the larger area of the basin.
Yeah, if you look back at like the water level maps that have been presented from Chapter 3 and stuff, it's pretty good distance between there and, the center of the, pumping depression from the district pumping, so.
Which
Our
is
water
confined.
moves slow, so.
Our family has had 2 historic wells in that area, and they just abandoned them because the water quality was so bad.
Yeah.
Oh, right. So firsthand. you've had the experience firsthand. And yeah, Mike just mentioned something that that area of the basin, it's questionable where the confining layer, if the confining layer extends past that, and so it may be just a different conductivity material, so it just may not move into the confined areas as easily.
To back up on the other question, have you ever, I know you shut those wells in for a day, day and a half, and you let them build up. Have you ever thought about getting any data from the buildup itself, the water level increases, and looking at that and seeing back to permeability and understanding flow? There's a lot of data you can get going the other way, and you can do that in all your wells and understand flow and maybe understand the productivity of each of these wells. That may impact the types of wells you choose. Just something to think about.
Well, we typically ask Mike and Robert from Pueblo Water Resources to do those calculations. So we have run a number of, step tests and 100-minute tests, and you can kind of get the transmissivity and conductivity of the aquifer material. They then take it and run it through an equation and can kind of estimate both well performance, but also aquifer parameters. And so, Mike, I'll let you.
Yeah, and when we work on a new well, we do look at the recovery data, and we analyze that as kind of a check on the drawdown data, so that we get the aquifer parameters from recovery data and compare it, and they're usually pretty close.
Yeah, the recovery data is better because when you're doing an aquifer test, the pump speed can vary or something else could happen. The pump could fail or somebody could kick on their well next door. But when it's recovering, the pump rate isn't going to vary. The pump isn't going to fail. It still could be subject to interference, but it's better data generally.
But it has to be a controlled test. You have to know what the rate was and how long it was pumping and what the total drawdown was. It has to be a controlled test still, but it is valid data.
Just a thought on back up on Arroyo Paradon. I think Ryder Brothers drilled a well there in the last 10 years, and I understand the water quality was very poor, so maybe their data might be helpful if you can go back to those guys and find out what's really going on over there.
I've got a water quality question. So I was just looking at the information that the Water District sent for the 2 samples taken, I think it was May and November, from the 2 wells. And both of them showed that the chlorides and TDS actually improved in November from May, which I would have guessed the opposite would be true. And I'd seen this on previous reports too, and thought it was somewhat of an anomaly. But does that make any sense to you, or do you see it in the results that you've gotten from other wells where it's actually improved between May and November?
I'd have to go back and look at that. I don't know, Mike, if you have any.
Yeah, I'd have to look at it, but typically the quality fluctuates a little bit, so I can't really explain why that is. Maybe you're just pulling from some different parts of the aquifer that are fresher, or I'm not sure. But they do fluctuate a fair amount.
Yeah.
Well, that explanation might be it, because definitely later in the season we're pulling from deeper.
Right.
Right.
You might be pulling less water.
And pulling less.
Right. Yeah, and so there may be a flushing effect from the spring rains, if there are any, that dilute the level of chlorides that may be in the water that's been sitting in the formation enough to leach out chlorides.
Is the fluid level lower or higher? Is the fluid level the same?
No, lower.
It's usually lower in the fall, right? Because it's the end of the irrigation season. Yeah.
All right, any other questions? I did want to, I know that we've talked about this, the Sentinel wells. So the Sentinel wells, which was representing what we were calling Section 30, which is right there on the coast. We've made a determination on the technical team that it's going to be a good well for us to monitor for seawater intrusion, where we're taking water quality samples and measuring the chloride levels, and then we'll set we will set contours such that we can say, okay, you know, if it gets above 100 at this first contour line, then we have to start thinking about how do we reverse that or stop it from increasing. But then what we're really managing towards is that MT line, which is the minimum threshold. It's the first active well closest to the coast in that area. And so we don't want to go over a value of 250. And we picked 250 because it's a drinking water MCL, secondary MCL, where you can start to taste a little bit of salt. But what we didn't really consider, and it dawned on me as Dave was giving the presentation, is we really haven't heard from folks who do agriculture whether there's a level that's problematic for either avocados or greenhouses in that area. So I don't know if you have any experience or thoughts on chloride levels with respect to agricultural needs, but that would be great to hear if you do.
Yeah, I can bring it to the next meeting because definitely have that. And in this particular case, we grow lemons, cherimoyas, and avocados in the same orchard with water that has a high chloride, high TDS, and the cherimoyas are the least affected, and the lemons after that, and the avocados definitely, you can see it in the tip burn and the browning and all of that. So that seems to be one of the ways that growers get around the problem is crop selection.
And do you know what those levels are?
Not off the top of my head, but I'll bring the information at our next meeting.
And what about greenhouses?
Most of us use the RO, so that's why it becomes a little bit of a non-issue.
Yeah, is there a level at which you cannot use RO or you don't have to use RO, or is it just preferred?
Actually, in some cases when the RO broke down, we would just run the regular well water, and actually the well water has been really good in this area. So
Yeah, I think below, in most wells, at least we show on our data, it's below 100, and that seems like it would be, you know, good for ag, but again, I don't know. But maybe if we're holding the line at 250, that may be too high for agriculture. So it might be something to.
Case, do you know how low the RO water gets?
Parts per million. Yeah, well, I think it goes down to 100 parts per million. So
The other thing that occurred to me is that at least in our situation, and I'm sure other growers, we mix the water, district water and well water, either mix it at the same time or alternate irrigating. And so that has an effect where looking straight at the well data isn't going to really tell the whole story. And I'm not sure. It's almost, you know, we may go to that point of, you know, an acre of avocados needs this much water, and trying to figure out, okay, how much came out of the meter and how much came out of the well to see what that balance is.
Yeah, I think I don't know off the top of my head what the district's chloride levels are, but they're certainly below 250. They're probably in the neighborhood of 100, and the TDS is around 650, I believe, for district water, which is pretty typical of many groundwater wells in the basin.
You know, it may be that the Ag Advisor, DC Ag Advisor service might be able to answer that question, or at least give some quotes. Yeah, we might be able to tap into, you know, some academic research.
We are in communication with them, so that's a good point. All right. Yeah, so back to this Section 30 Sentinel wells. What we've been struggling with is whether to use those wells for level, because we've created a mechanism to make sure seawater intrusion is addressed. But whether those wells right along the coast are representative of the water levels that affect pumping or water storage that affect the storage in the basin. We're not convinced, so I wanted to re-mention that because it's something that we're still grappling with, and we don't know. What we don't want to do is shoot ourselves in the foot by saying we're going to use these Sentinel wells as level and storage RMS wells, and then immediately have an effect along that coastal area that is basically we have to curtail pumping in that area pretty quickly. So that's one of the things that we'll be working on as a technical team on the water level and storage RMS wells. All right. Mike, did you have any other? You had a couple notes? Okay.
No, I was just, when we were talking about the 250, I was wondering about the ag effects as well.
Yeah, and so currently we have 3 sets of RMS wells, I guess you could say. One is for water levels and storage. One is for, and those are depths, measurements of depths. One is for seawater intrusion, which will be chloride levels. And then we'll have a water quality set, which we haven't decided yet, but that we'll be talking about next meeting. And, you know, to the degree we can combine those and utilize the same well, we will. That makes sense. And to the degree we can get transducers to measure continuous measurements over long periods of time, I think is something that we would want to do as well. Again, you know, it seems like we're trying to decide these things that we could almost shrug our shoulders at, but in the end, I wanted to connect it all up and say, you know, we're going to get into the projects and management actions, which are kind of well, how do you manage these if you do start seeing exceedances of the MPs? And so as we're sort of setting up the framework for measurement and compliance, we're really setting up what's going to happen when we get out of compliance. Are we going to have to spend a lot of money? Are we going to have to curtail pumping? Are we going to have to import more water? Those are all questions that are going to be driven by the results of how well we can comply with these. The backstop, of course, with, you know, there are certain criteria that DWR has put out there that we have to, as Dave puts it, pass the red face test and say, look, this is a representative well. This is why we selected it. This is a reasonable minimum threshold. This is why we selected it. In the end, DWR is going to have to bless our plan and say, you have complied with the requirements of SGMA. And so that's our balance, is we want to make sure we're not shooting ourselves in the foot with you know, immediate costs and immediate management actions. But at the same time, we want to be able to comply with the requirements of SGMA as DWR is going to review our plan. So any questions about kind of that connection? We haven't been really talking about it that much, but I think it's important for all to understand that we're talking about these things, but they will have an effect on the next discussion that we have with management actions and projects.
The only part I'd ask about is, I guess your philosophy around the zones. We didn't talk about that today. I guess there's 3 zones in this reservoir. That they're interconnected, right? So it's all one big happy family, and fluid levels are fluid levels, and that's kind of the approach you guys are taking. Is that correct?
It's a hybrid. So there's a concept called the principal aquifer in SGMA, and it's basically saying you have to define what is the principal aquifer, and we've defined it as everything, including those zones that are or not alluvial, but deposits, unconsolidated deposits. So some of those deposits don't have saturated, they aren't saturated, they don't have water that's easily accessible. Some are not very, they don't have very high conductivity, so water doesn't move through them or saturate them, or doesn't, there's not a lot of storage in those sections. These zones were identified during the district's history in the basin as highly permeable, and they have good storage coefficients. So there's a lot of water that migrates to those zones and then moves laterally. So if you perforate your wells in those zones, then you're able to access more water more quickly. And so those aren't the basin, or they aren't aquifers, they are zones within the principal aquifer. So we treat the whole basin as one unit. But that said, those zones are the easiest places to get representative sample water levels and samples, water quality samples, because a lot of water moves to those zones.
I can see a potential problem. If there's not too much vertical exchange between zones, if you're monitoring salinity, say in your deepest zone, and you're running into problems there, how do you know that that's creating problems for your principal aquifer that maybe is several hundred feet above that?
It's a great question. You want to take a stab at that? We've
Well, I
kind
mean,
of talked about this.
The Sentinel wells are the only place where that's specifically being, the Sentinel wells are the only place where that's specifically being, addressed and evaluated right now. And clearly, we're seeing it in the C zone and not yet in the B and the A zone. And, in all likelihood, as the district installs more monitoring wells, along that line, we'll find out more. I don't know what else to say than that. There's going to be some depth discrete at the El Caro monitoring wells that are going in this year, right? So we'll have some information there, but that's pretty far inland. It's unlikely to be, at least initially, have any observed effect from seawater intrusion.
You touched on the issue of, do you set MTs at the Sentinel wells, particularly on water levels? And it seems to me that you've got a lot of learning to go on. You don't have much of a data set yet.
Yeah,
you're going to be learning a lot.
Yeah, there's a term that gets tossed around a lot in geology called layer cake geology. And it's like you see things and you assume what you see there is everywhere, like A, B, and C zone. Like, A, B, and C, that's the icing, and everything in between is the cake, or vice versa, or whatever. And you think, okay, well, those aquatards are laterally extensive and competent, and that's hardly ever really the case, right? Because they're deposited by fluvial systems that move around through time, and so people make assumptions based on this layer cake geology assumption, and in actuality, they're connected somewhere, we just don't know where. So that's another reason why, it makes sense to define the principal aquifer as just everything above the bedrock, right? Because it all moves around. Now, they obviously have found those, those aquitars to be extensive and those A, B, and C zones to be extensive, because plenty of wells show that. But that doesn't mean it's everywhere,
A better solution. Kind of to that end, some of the places where we think about doing wells, we talk about the cold water formation and the Sespe formation and the water-bearing capacity of those. Are you dealing with that within the basin we're talking about, or is it completely different?
Do you recall, I think the cold water is part of the unconsolidated, but the Sespe is not?
No, the cold water is a consolidated bedrock well, and it's outside of the districts or the boundaries of the basin. But it is a resource typically through this coastal area. Yeah, there's.
Our basin is granular. It's probably created through seawater retreat, seawater advancement, seawater retreat. And so you have these marine sand layers between, sandwiched between silt and clays that are less permeable. So you have a combination of sources of deposits, whereas the consolidated rock formations are just, they've been there for a long time. They've consolidated and hardened through some process, some geologic process.
Yes, sigma, for better or for worse, it's basin-centric, and basins are usually defined as a collection of unconsolidated sediments. So these bedrock formations that might produce perfectly good wells up in the mountains, that's a problem for another day. It has nothing to do with sigma right now.
Yeah, they're not regulated by sigma.
No.
So any consolidated fractured rock well is not regulated under sigma.
In this process of getting more information, and I might have mentioned it to you before, Bob, and I mentioned it at this table before the meeting, and that is where the water district used to be on, I think, 7th Street. There was a well there, and they actually were bottling and selling water, so it was a commercial well, and I don't know what condition it's in now or if it's been sealed or whatever, but I'm just wondering if it has some baseline information that would be helpful, because certainly if they were bottling the water, they would have to have a lot of what they're starting with, the quality of the water and what it was, however they cleaned it up to sell it and that sort of thing. And I just wonder if it would give any insight into saltwater intrusion or whatever. It's really, not that far from the coast. The problem I see is I don't think there are any other wells to compare anything with in that part of town. But just as to throw out that bit of information that there might be something out there that could be helpful.
Yeah, I don't think they've been bottling that water for quite some time. I think it's a studio now, but yeah, that well still exists and it's capped, but it's a removable. We can remove the cap. I don't know. I don't think we sample for water quality there. I think we do water level measurements, but that would actually be. It's named as one of the potential RMS wells, though, for the seawater ISO contour. All right, any other questions, any other comments before we wrap it up? All right, well, thank you, everyone. We'll see you next month, second or third Wednesday. I'm getting too many, I have too many meetings. Third Wednesday.
The next advisory committee meeting?
Fourth Tuesday, so, so it's the,
Fourth Tuesday?
I think it's the same as, March is the same as February, yeah. 28th, I think is right. Yeah. Yep, 28th. All right.
All right.
One more down.
I can see how having transducers, continuously recording transducers and
Yeah.
really.
Yeah, and that's, when we did the Century wells, we were kind of like, or the Sentinel wells, okay, let's put some transducer. We also tried to do water quality, but it was too deep and